Hello, I welcome you all. The problem reads that during operation, the jackhammers strikes the concrete surface with a force which is indicated in the graph. To achieve this, the 2 kg spike S is fired into the surface. At 90 meters per second. Determine the speed of the spike just after rebounding. This problem is coming from the Engineering Mechanics and Dynamics 13th edition by R.C. Hibbeler. So let's see what is happening. So we have been told that the original or the initial velocity of this particular spike is at 90 meters per second in going down. So we have this is the direction, and this one is our V initial, which is equal to 90 meters per second. And then as the spike interacts with the concrete, then we have this particular force. This is the force, the reaction force from the concrete, right? Okay. And then this rebounding force or the bounding force is velocity in this direction. Okay. This is the velocity when the spike moves up. Right? This is what we want to find. Right? Okay. And we are going to use the principle of linear impulse and linear momentum. Remember, we're able to solve this using the equations of motion coupled with kinematic equations. We can also solve this by other techniques, but in this we are going to use linear impulse and linear momentum. So we know to say impulse is just force delta t. When you look at this is just the area under the curve, right? This area under the curve. Okay. Area under the curve is equal to the impulse. So let's write down the equations. So we are saying summation of the force delta t is equal to the change in the momentum, where delta v is equal to v final minus v initial. Our v initial in our case is minus. Okay, it's minus, it's in the opposite direction, minus 90. Okay, and our v final, that's what we are looking for. And then, like we said, we are saying area under the curve. Area under the curve is equal to F delta t, and this is equal to M dV final, right? Okay, and this V dV final, we say this is just equal to V final minus V initial. So the area there, it is half times the horizontal axis, which is 0.4, mind you. The time is in milliseconds, so multiply this to bring it to seconds, to 10 times 10 to the power negative 3 times the height, which is 1500. Mind you, is in kilonewtons. We want it to be newtons. We multiply it by 10 to the third 3. So we are saying this is equal to the mass, which is 2 V final minus 90, like that. Okay, and therefore our V, okay, which is up like so, is equal to V. So this is just equal to V final, which is just equal to V. This is equal to let's work it out. So 0.5 by 0.4 by 1500 divided by 2 and minus 90. and this gives us a 60 meters per second. Okay, right, so this is the velocity just after rebounding. Okay, so I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye, and I'll see you in my next screencast. So this one is force from the concrete. Let me just indicate. Okay. Alright, bye bye, and I'll see you in my next screencast.